we are going to review the basics for how to interpret a position graph. On a position graph, we usually only draw quadrant 1. That's the positive quadrant, and that's because time is positive, and in this class, position is always positive. And on the axis, the bottom axis is time, which means it's usually being measured in seconds. And the side axis is position, which means it's usually measured in meters. Now remember that we abbreviate position with the letter X. So you will often see position versus time graphs drawn just with an X and a T. It's weird to see X on the y-axis, but we do it all the time in physics. So the first thing we need to talk about is position. Notice that position is on the side axis. So anywhere the object is along this axis is telling you how far away the object is from the reference. The bottom corner is given position 0. If the graph is drawn high above 0, that means that the object is far away. And as the graph comes down closer to 0, it means that the object is getting near the reference. So again, the top of the graph, that's far away, and down near the axis, that means that you're close to the reference or near. Now, if the position of the object stays the same, you get a really boring graph. You just get a flat line. A flat line just means that the position didn't change. We don't get a lot of flat lines in this class because we're looking at objects that are moving. They're doing something exciting. So, we're going to get graphs that slant up and down. If the graph slants uphill, that means that the object is moving away from the reference. Notice that it starts down low, which is near 0, but then as the graph progresses, we get higher and higher and higher up the vertical axis. That means we're getting further away. When the graph comes back down, or you have a negative slope, this means that you are coming toward the reference. Now, if you're just looking at the signs, that means that positive slope means away and negative slope means towards. That's something you just need to remember. Now, how steep the line is tells us how quickly the graph is changing. So let's look at some examples. If the graph is not very steep, okay, that just means that the position is changing very slowly. So I'm going to write the word slow here. If we calculate a number for that slope, we will get a small number because it just is not changing very quickly. On the other hand, sometimes we get a graph that just spikes up. It's very steep. That means that the position is changing quickly. So I'm going to use the word fast. So steep graphs mean the object is moving fast, and graphs that are not steep are moving slow. Remember that we use the word velocity. So one of the things that you need to memorize is that slope of position equals velocity. This was a fact that a lot of people missed on the last test. So again, the slope of your position graph is the velocity of the object. They are equal. The last thing we need to talk about is something called the initial condition. The initial condition is just where the graph started. So I'm going to put some numbers here. 0, 1, 2, 3, 4. all you have to do, the graph that I just drew, you just have to look on the axis. So in this case, notice that the graph started next to the number 2. That was the initial condition, or we also call it the initial position. And you get it just by looking at the y-intercept, or where the graph started on the axis, and that will tell you your initial condition.